Alrighty, class. So we're going to go over lesson 4 today together. Lesson 4, we're going to be talking today about surface area of prisms and cylinders. There's two parts. We're going to start off with prisms and cylinders, and then in part 2, we will move on to surface area of right pyramids. And right pyramids basically is just a fancy way of saying that the apex of the pyramid is right on top of the center of that base. So the apex, which is like where they meet of the pyramid, is right on top of the center of the base. So the center of that triangle or whatever is at the bottom, and cones, right? So we're going to start off over here, right? And we're going to start off with our beginning of our lesson, which is basically going to cover what the object is and what its 2D net is. So just overall, just starting off, we're going to start off with what is surface area. So surface area is basically a sum of the area of all faces or surfaces of a 3D shape. So how I like to put this is, if you were going to build this shape, how much stuff would you need to build the shape, right? So how much of the stuff would you need? How much area does it take up? Okay, so we're just going to start this off by saying, let's match the 3D object to its 2D net, right? So if I was to take this box and I was going to dismantle it and make it flat on the ground, what would it look like? Before we even start that, let's label what do we call these things. So this is a rectangle connected to another rectangle through these parallel lines, right? So this is something we call a rectangular prism, right? Then we have this thing right here. It's a circle attached to another circle through parallel lines, and we call this a cylinder, right? Then we have the square based. It's not a pyramid. It's not a prism because you're not attaching via parallel lines, but you are attaching to an apex and it kind of looks like a pyramid. So we call this a square based pyramid because they're kind of all joining on the side via these little triangles, right? And then last but not least, you have a triangular base. You have a triangular base and they're connected via parallel lines, right? So then this is something we called a triangular prism because prisms are always connected via little rectangles. So I'm just going to go back here and I'm going to say, all right, we labeled all of them. So pause this video and you try by yourself. Try to go back and find out, okay, which one is a rectangular prism if I lay it down? Which one is a cylinder? Which one is a square-based pyramid? And which one is a triangular prism? So pause it and then come back. So let's start off with the rectangular prism. I know that a rectangular prism, everything is a rectangle. So I'm going to go back here and look. Which one is everywhere in a rectangle? Nope, I have some triangles there. I have some circles there. I have some triangles there. So it can't be that. So I know it's this one. I know that it's that one, right? Really easy. The first one's always usually the easiest. Then I know I have a cylinder. So I know my cylinder has two circles at the top and then a little rectangular piece in between it, right? Which one has two circles? This one has two circles, so it's this one. My square-based pyramid means that I have a bunch of triangles sitting on a square base, right? I got that square base at the bottom, and then I got a bunch of triangles popping out, right? Where is that one going to be? Right here, we got a square base and a bunch of triangles popping out. Okay. And then that leaves us with our triangular base pyramid, or prism, right? Which is just this thing over here. Again, we have these triangles with these rectangles to connect it. Okay? Alrighty, so we got that. We're just going to move on now. So, in order to determine the surface area of shapes, what you're basically trying to do is you go back here and you look at what is the surface of face 1, 2, 3, 4, and 5. Right? I want to know what the area of all the faces on this particular object are, and then you add them all up and you get the surface area. Okay? So it feels complicated, but don't worry, we'll walk through it. Before we even get started, you always want to keep your formula sheet on you. I'm going to try to make you not memorize, but kind of understand why we're using the formulas that we're using, because if you understand the why, the how becomes easier and you can actually think about questions, right? But always keep your formula sheet handy with you because you just want it there for easy access and easy reference to things. Okay? And sometimes it'll actually tell you the surface area formula. So for a rectangular prism, it actually does tell us the surface area formula. It's just area is equal to 2 width times height times length times W times length times height. And again, I'm going to show you where that came from, but you can just use the formula. Okay, so I'm going to say length is 12, width is 3, and 8 meters is the height. I need to remember that in my rectangular prism, if I was to lay it flat, I would have this face right here, right? And then this face also has a back face, right? So we can't forget that this face has a back face over here. So that is going to be length times height. So 2 length times height. That's where that comes from. Because I'm doing 12 and then the height, I'm taking the area of that. Now, I also know I have this shape right here, this green one. That area, if we pull out the square, is going to be 3 times 8, which is also width times height. I also have 2 of those boxes here. See? I have this green box, and then I have this one. Then I also have this top box over here. And this bottom box over here. Right? This one has a length and width. So then I do times L times W. So that's where that came from. Right? And since I have 2 of each of these, we do 2 times length. This shouldn't be multiplied by, it should be plus. Apologies. Plus, 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 plus. So let's just go put in our numbers, right? So I know that the first box I have 2 times width, which is 3 times H. So I'm just going to put them in the color that they are in, but you don't have to do this color coded. I'm just doing it for the purposes of showing you. So the green box has a 3 times 8, right? Plus the blue box is going to be L times W, which is just 12 times 3, plus our last one is length, 12 times height, which is just that front-facing box that we have. Okay. The orange box, which I didn't do a really good job of coloring in, but you get what I'm saying. Okay, so those are our numbers. So let's just go in and put them down. Let's just fill in this equation. So I'm going to do 2 times 3 times 8 is just 24. Oh, sorry. Yeah, 24. 12 times 3 is 36. Right? And then 12 times height. Sorry, I forgot to put that in. 12 times height, which was 8. Okay. And I'm just going to do 12 times 8 is equal to 96. Right? Gotta always add everything in the brackets first. 36 plus 96 plus 24. So then I have equals 2 times 156. And you are going to have much better use of your space than I did. And make sure that your form is good. So then area is equal to 2 times 156. Multiply that by 2. And I'm left with area or surface area. Surface area is equal to 312 centimeters squared. And that is my surface area of this rectangular prism. So again, like I said, you just want to know where it's coming from, just in case, I don't know, what if I said that was an open box, then you would know that you didn't have to do 2 times length times height at the top, right? Because it would be open, you wouldn't need material there. So while you can always use the surface area formulas, sometimes you might need to manipulate them, so it just makes more sense for you to understand where those formulas are coming from. Okay? Alrighty. So we're gonna move on, right? And again, I'm always gonna work with trying to use as much of that manipulation as I can, right? But I know that I have this triangular prism here. So the orange, I'm gonna have my shapes all together, right? Oops, this is not a really ugly triangle. So I have 2 triangles that are connected by this rectangle on this side. I've got another rectangle doing the same thing on the other side, right? And then I have this rectangle at the bottom, right? So I'm gonna have area of the base, which is just area of the triangle, right? Which is just base times length times 2 divided by 2. So right, base times height divided by 2. Then I have the area of the rectangles, right? So I have side rectangles. We'll say area of the side rectangles, right? Which is going to be this rectangle. If you go down, it's going to be the length of the side multiplied by the height of the triangle, right? So I'm just going to label these because it's easier for me to do that. So I'm going to label this as A, I'm going to label this as B, and I'm going to label this as H, right? So I know that the side is going to be B plus H. Maybe I won't label it as H. Maybe I'll label this as D. Right, so I know it's going to be B and D times 2. And this is going to be times 2 as well. Right? And then I'm going to have the area of this bottom one right here. Take this bottom, right? I'm going to do area of bottom rectangle. And there's only one of those. So it's just going to be D times A. Okay? So let's go and find out these different things. I actually don't know what B is, but I do know what the height is. And given what I know about Pythagorean theorem, I can find B. So let's do that. Well, let's find out. And you can also label that side as L, as the length of the rectangle. It's up to you what you want to do. So I'm going to do A squared plus, let's label this C so that we're consistent, right? So let's label this C. I like the C. B squared equals C squared, right? So I have A, which is 6 squared plus 4 squared equals C squared. So 6 plus 4, oops, sorry, it can't be 6 because this is 6 centimeters and we want half of that. So the area from here to here is actually 3. So I'm going to do 3 squared plus 4 squared equals C squared. And we've seen this before, so we're going to do 9 plus 16 equals C squared. 25 equals C squared. So we know C is 5. Right, so this is going to be 5, that side length. So now we can find the area of the triangle. So let's find the area of the base. The area of the base is equal to base, which is 6 times height, which is 4, divided by 2, right? So area of the base is equal to 24 divided by 2, right? So area of the base is equal to 12. right? There's 2 of those, so don't worry, we'll do that later. Now we want to go over area of the side, so I'm going to put that in this color, area of the side triangles, and there's 2 of those, right? So a side is equal to, I'm just going to write area of bases equals 24 because we're just taking that and multiplying it by 2 of bases. Area of the side is going to be C times D, right? Because you're doing this length over here, multiply this width over here, equals 5 times D, which we said was 13. 5 times 13 equals 65, right? Times 2 because area of both side rectangles is 65 times 2, which is 130, right? And then you need the area of the bottom, which we said was area of bottom, equals D times A, which is just D times 6, equals 9 times 6, 54. And now we're just going to add all of those together, right? So we're going to do area of the base I'm going to write this here. So area of bases plus area of side plus area of bottom rectangle, right? So I'm going to just take those numbers and I'm going to say, all right, I have 24. So surface area equals 24 plus 130 plus 54. And that is going to give me oops, I made a mistake here. This should be 6. 6 times 13, so 6 times 13 is going to be 78. This is why you should not speed run through your assignment. Right, so then the area of the 2 sides is going to be 78 times 2. It's going to be 156. Ready? No, that's right. Silly me. It was 5 times 13. Right? And that's 65. I was right. I'm being silly. $65 times 2. Oops, 65 times 2 is equal to 130. So yeah, I'm right. So 24 plus 130 plus 54. So sorry, ignore everything I just said. Just keep moving. And then there's going to be 208. So surface area is equal to 208 centimeters squared. Okay. So we're just going to move on now. And again, you can use the formula. You should get the same amount. You just got to be careful when you're using this, that you are using the right volumes for, or the right letters for L, A, and H. Okay, so just be mindful of what you're labeling your triangular prism. Alrighty then, we're gonna get started and we're gonna move on now. Right, so we're gonna move on to our hexagon. Right, so I'm sorry, but it's just over here. So again, we're We want the area of the hexagon at the top and at the bottom, and then the area of each of these little rectangles. So when we're looking at the surface area, our surface area is going to equal 2 times the area of the hexagon plus, there's going to be 6 rectangles. 6 times the area of the rectangles. And this is one of those that is actually not in your formula sheet, so you actually have to think about it. So let's go back here and find the area of our hexagon. So like we remember from last class, the area of the hexagon, so let's just do area of hexagon. Is equal to 6 times the area of base of the triangle. So base times height divided by 2. So let's just do that 6 times. We're going to take this triangle. I'm going to pull it out so you can see it properly. Right. I'm trying to make this a nice looking triangle, but it's not happening. So 13, and the height is 11. So you can see it there, it's 11. 11, so base 13, height 11, divided by 2. So let's find the area of the hexagon. So I think Victor pointed out you could just cancel that 6 and 2 out, so you're left with 3 up here. So 13 times 11 equals 143 times 3 is equal to 429 is the area of the hexagon, right? So I'm going to start AH. Then we want to find the area of this rectangular piece, right? So I'm going to put this in maybe the green so that we can keep everything separated and clean. So area of rectangle is just the base of, so then it's 13 equals 13 times the length, which is 29. So let's just put that in, 13 times 29. It's equal to 377. Right, and now I'm going to just take the surface area is going to be, surface area is equal to 2 times the area of the hexagon, 2 times area of the hexagon, plus 6 times area of the rectangle. Right, so I'm going to do 6. So 2 times 429 plus 6 times 377, and I'm just going to do the math. 2 times 429 equals 858 plus 6 times 377 is 2262. Add 858 to that. So my surface area is equal to 3. I'm going to do that. Surface area is equal to 3120 centimeters squared. And that's my surface area. Okay. Oh, I had so much space to do that. I don't know why I did it this way, but you know what I mean. That all went there. I just wanted to make things apparently harder for myself. All right. So, example 2. It says, what amount of plastic is needed to make a cylindrical cup? And I'm highlighting this word because it's important. Cup with a radius of 4 centimeters and a height of 10 centimeters. So I know it's a cylinder. So let's just go in and draw the shape. So I'm going to draw in a circle, right? And then I'm going to draw in my little thing over there, and then I'm going to draw this in. Okay. There you go. So I have a cylinder. I know that the radius, so from here to here, that's going to be 4 centimeters. I know from the top to the bottom is going to be 10 centimeters. Right? One thing I need to remember is that this, because it's a cup, is not there. So While in theory, I could go and I could look at my formula for a cylinder, which is basically just area is equal to 2a base plus lateral surface, so 2 pi r squared plus 2 pi rh, right? We can't do that because we don't actually have two bases. We only have one base. So my surface area is actually going to be 1 times the area of the base, right? Because we only have one circle, plus the area of the lateral surface. Right, so this is where I need to be able to modify my formula. So my area of the base is just going to be pi r squared because that's the area of the circle. Plus, my area of the lateral base still is 2 pi rh. Right? And when you lay out flat your circle, right? You can if you lay out flat that's what it looks like, right? We know that this length right here is the circumference of the circle, so that's 2 pi r, and then this length right here is h, so that's why the lateral surface, that's the equation for it. Okay, so you have 2 pi r, we have pi, we know what r is, it's 4, squared plus 2 pi 4 times height, which is 10, and now I just got to put everything in. So 4 squared is 16 times pi, plus 4 times 10 is 40, times 2 is 80 pi, and I'm just going to put that in. 16 times pi is 50.265, right, plus 80 pi is 251.327, right? And I'm just using as many of the decimal places as I can. I'm going to add those two together, so I'm left with 301.59, which is me 301.6 centimeters squared. Okay, and that is the answer. That is how much the surface area is, so therefore we need 301.6 centimeters squared of plastic for the cup. Okay, still recording. Awesome. So we're going to move on and we're going to do example 3. So example 3 is as stated. So it says a covered, so that means that all of the sides are going to be there. A covered garbage container is to be built so that the measurements are 1.5 meters by 1.2 meters by 1.0 meters. Draw the diagram. And the reason that I explicitly ask you to draw the diagram is because the diagram is arguably the most important thing for us to be able to visualize what's happening. So I'm going to draw it in. Do it to the best of your ability. I am no artist, but I also have an iPad that corrects my mistakes. So, I do not expect your diagrams to look perfect, but as long as I have an understanding of what you're doing, that's all that really matters. Okay, so mine looks kind of like that. So I'm just going to go in and put in my dimensions. So I'm going to say this is 1.5, right? So it's 1.5 by, I'll make this 1.2 and I'll make this 1.0. Is this to scale? Nope, but that's okay. Okay, so that's what that looks like. Calculate the amount of plywood needed to make this garbage container. When it says to calculate the amount of something, you're looking for surface area. When it's asking you how much of something can fit in there, it's asking you for volume. Right, so this is asking for surface area. Let's go back, look at our equation. This is a rectangular prism, so our area, our surface area, is going to equal 2 times width. So width times height plus length times W times length times height. So let's go define what's what. So I'm going to say length, width, and height. Okay, and in theory, whichever way you label it should give you the same amount. So oops, I'm just going to go back and change this. So surface area is equal to 2 times 1.2 times height, which is 1.0, plus 1.5 times 1.2 plus 1.5 times 1.0, right? And we're just going to go and solve. So let's do the inner brackets first. Let's do 1.2 times 1.0 is just going to be 1.2 plus 1.5 times 1.2 is going to be 1.8 plus 1.5 plus 1.0 is just going to be 1.5. Right, now let's add those all together. So I'm going to do 1.2 plus 1.8 plus 1.5 is going to give me 4.5. 4.5, we're going to multiply the entire thing by 2. And that's going to give me 9. Surface area equals 9. Okay, so 9, what? 9 meters squared equals surface area, because we always want to put our meters in, right? Therefore, you need nice. I don't know why it's doing that. You need 9 meters squared of plywood. Okay. I think I thought my y was a 1. So it says the plywood comes in sheets measuring by 120 centimeters by 240 centimeters. How many sheets of plywood are needed to build a garbage container? First things first, you gotta get this 120 and 240 to the same units. You can't be dividing units without putting them in the same units, right? You can't be dividing numbers. So let's change the 120 centimeters to meters, right? And we know that we can do that by doing 120 divided by 100. So it's going to be 1.2 meters. Let's change the 240 centimeters to meters. Same thing, divide by 100 is 2.4 meters, right? So we know this piece of plywood that we're trying to buy is 1.2 meters by 2.4 meters. So maybe I will make this look a little bit more realistic and say 2.4 by 1.2. Okay. Now, I need to find the area of each plywood because I have the total area of how much I need. So I need to find out how much is each plywood. So let's find the area of the plywood. Area of plywood is equal to length times width, right? Just area of the rectangle. So we have 2.4 times 1.2 is equal to 2.88 meters squared. So each plywood is worth 2.88 meters squared. I need 9 meters squared in total. So number of plywood is equal to how much I need, surface area of plywood needed, divided by how much each one is, surface area of one plank, because I think, or sheet, whatever they call them, right? So I'm gonna take, I need 9 centimeters, I need 9 meters squared. I know each one is 288 meters squared. So I can just take 9 divided by 2.88 equals 3.125 sheets of plywood. If I go to the store and I ask for this, they're going to be like, no. So therefore, I need 4 sheets. And it feels like a waste but it is what it is of plywood. Okay, and that is how to do a surface area of prisms and cylinders with a few examples. So try doing the homework for those ones. Now we're going to move on to doing right pyramids and cones. Right, so how do we do the surface area of a right pyramid and a cone? So to calculate the surface area of a right pyramid, right, is going to be, you have to add the area of the base, and then you have to add the area of all the faces. Same thing we've been doing so far, nothing really different here, right? But one thing you want to remember is a right pyramid and a right cone is a pyramid or a cone in which the peak of the pyramid or cone is right over the center. The center of the base. And that's just important to remember. So because then that just means that all the sides and all the faces are equivalent to each other. So this formula is straight out of your text, out of your formula sheet. We have them written there, right? So what it's going to be is you're going to be looking at b squared, which is just this length right here, right? The base of your pyramid is going to give you the area of the base because it's a square base pyramid, right? So the area of the base is just all the sides. Length times width is just going to be, because b is the same, you're going to do b times b. You're going to do area of the triangle, which is this right here, right? And the important thing to remember here is it's times s, not height, because height is the height of the pyramid. So the height from the bottom base all the way to the apex of that pyramid. S, this S, is talking about the height of the face or the triangle. Alright, so what it's talking about is if you look here, this is what S is. I'm just going to draw it out. S. Right? So that's what we're looking at. Height of the triangle, not the pyramid. Same thing here, right? When you're calculating the cone, it says right here you have area of the base, which is just the area of the circle, right? So it's just pi r squared. Then you have area of the lateral circle, which is, you're looking at this, right? What's the area of in here? Sorry, it changes to a diamond automatically, but what's the area in here? So that's pi rs, right? And then you have area of the base plus the area of the lateral surface, right? But S, it's important to remember, is this right here, the height of the actual surface, right? Not the height of the cone. So that's really important to remember. It's just the area of the slant. So that's why it's called S. It's called the area of the slant. And you find that, so I'm going to say this is slant height, not height of cone. That you only use in volume, right? Because we want to know how much empty space is on the inside. Okay. So we're just going back. What is slant height? It's kind of hard to explain. It's more easier to show you, but it's basically the height of the outside edge. Triangle, whatever it might be, right? So the height over here. So height of the shape. So if I was to lay this flat, what would be that height? And then the height represents the actual height of the pyramid, which we use to calculate the volume. Okay. The surface of other pyramids that your formula sheet doesn't have for varying bases, you will be given in your homework. For those, just simply add up the area of the triangles, then add up the area of the bases. except the base is not a square, right? So you're doing basically the same thing. What you're doing is, instead of doing length times width, right? In a hexagon, you might be doing 6 times BH divided by 2. If you have a pentagon, you might be doing BH divided by 2 times 5, just depending on what they are. So what you're going to do is, in everything else, you're going to find area of the base, right? Then you're going to find area of each triangle, right? Which is just, often you find the area of one triangle and you multiply by how many triangles there are, right? And then you add these two together to give you surface area. Okay? Use the slant height to find this. So, seems complicated, but don't worry, we know how to do this, so let's work through it. So we have the area of our cone, or the surface area of our cone. That's what we want to find. So we know surface area is equal to, we're just looking at the formula sheet, pi r squared plus pi rs, right? What is s? So s is this length right here. Do we know that? No, we don't. So that's s. So we got to find this slant height. But since I know that this is a right triangle, I can find the slant height super easy. We've done this before, right? So I'm going to say, all right, let's find slant height. I'm going to stop this from happening. Slant height. So I know slant height is equal to that s over there, and I also know a squared plus b squared equals c squared. So let's just draw this triangle out for myself. I'm just pulling it out of there so that I can actually work with it. So I have slant. I said this long length was 15, and I said across was the radius, which was about 5. So if you just go back up here and you look, this is 5, right? You know what it is. I just pulled out the triangle. So now let's just put stuff together. So we have 5 squared plus 15 squared, right? A squared plus b squared equals c squared, which is just s squared. 25 plus 225 equals s squared. 25 plus 225 is 250 equals s squared. I'm going to take the square root of both sides. S equals square root of 250 is about 15.9. Right, so that is my s. Now that I have my s and I have my r, I can just go in and use the formula. So I can say, all right, pi r is 5 squared plus pi r, my s is 15.9, right? Surface area is equal to pi 5 squared is 25, right? Plus pi, oops, I forgot to put the 5 in here. My r was 5, right? So let's just do pi 5 times 15.9, right? And I'm just going to do that. 25 times pi is equal to 78.53, and I'm going to use the 9/8 because I just want to keep as much as I can, right? Then I have, and it's fine if you don't use that. Your numbers will just be a little bit different, and that's fine. Then I'm left with 249.757, right? I'm going to add these two together, 78, and I just use the A and S feature, which means that I probably even have more decimal points. So my surface area is going to be 328.2964, blah, 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 blah. So I'm going to round it up to 2.3. Right, so my surface area is equal to 328.3 centimeters squared. I just took the units from here. And that's my answer. So we're almost done. We only have one more example left, so I want you to try that by yourself. So pause this video here, and then when you return, watch the solution. Pause the video, try it by yourself, and also I want you to actually try the unit homework, right? So try it by yourself and then come back and watch the answer. Okay? All right, welcome back. So we're going to try to find the surface area of the square base pyramid. I always like to start off by drawing out what my net looks like. I find it easier that way. So my net is going to be this, right? I got this triangle over here. Oops. We're going to pretend like these triangles are well drawn and that I am secretly Leonardo da Vinci and an artist. Okay, so we got that. Right off the bat, I'm just going to go in and draw which dimensions I already have. So I have 10, right? I have my apex to here, which isn't really like on this chart, so I'm going to leave it. And then I know that I need this center right here, right? So that's this part, the slant, or the height of the inside triangle. Right? So I need this, I'm going to put this in a different color. I need this green for a slant height. Okay? So I need that height because that's what the S is. So I can find the area of this square in the middle. So I know that surface area is going to equal the area of the square, right, plus 4 times the area of the triangle. I'm just going to put that in brackets. Area of triangle. Okay? So let's find the area of the triangle. I need, in order to find the area of this triangle, I need to know what the slant height is, because I can't find the area of this triangle over here, right? Can't find it without knowing what the height of that triangle is. I know the base is 10. Right? So let's go and figure that out first. You can even go back here, and if you look at area of a square base pyramid, you have your area total is equal to b squared plus 2bs, right? So even if you were looking at your area of a square base pyramid, you were going to look at area equals b squared, right, which is just this base, plus 2bs. You still need a slant height, so you can use either or. Doesn't matter which way you go about it. Okay? But either way, you needed S. So let's find S. We know that there's this triangle here that we can use. So I know that my height is going to be 12, right? The entire thing would have been 10, so we got to take half of it, which means that this is 5, right? And then we want to find this length. That's just my hypotenuse. So let's go do a squared plus b squared equals c squared. I'm going to do 12 squared plus 5 squared equals s squared. 12 is 144. 5 squared is 25 equals s squared. So 144 plus 5, just put that into your calculator, is going to give you about 169 equals s squared. I want to get rid of the square on both sides, so I'm going to square root both sides, right? So 169 square rooted is 13 equals s. And I like to just go back in and say, okay, this is 13, right? This is 13. So that means this is 13. So let's go in and use our formula. So either you could have done, I'm going to show you both ways to do this. So I'm going to show you the first way. We'll do this one in this color, and we'll do this one in this color. Okay, just so you can see both ways of doing it. They will give you the same answers. They are the same thing, but I'm showing you different logics that we use. So the first one is if you just did it straight by using this net. So I know that the area of the square is equal to 10 times 10. It's going to give you 100, right? Then you have 4 times the area of the triangle. So the area of the triangle is base times height divided by 2, right? Which is also, let's look here, base was 10, height was 13. So 4 times 10 times 13 divided by 2. So let's just do that. 10 divided by 10 times 13 is 130, divided by 2 is 65, times 4 is 260, right? So that's the area of triangles, And I know that my entire area, so my entire surface area, is the area of the square, area square, plus area of the triangles is equal to area of the square, which is 100, plus 260 is equal to 360 centimeters squared. Okay, if you wanted to do it by just using the formula from your worksheet, you can say SA is equal to B squared plus 2BS. My B is 10, my B is 10 squared plus 2. B is 10. S we found was 13. Right, so let's do that. 10 squared equals 100. 10 times 13 is 130. Plus 2 equals 260. Right, equals 360 centimeters squared. You got the same thing, right? Just depends on which way you want to find it. I care personally more about the y. Some people are okay with just plugging numbers in. As long as you understand which numbers to plug in and why to plug them in, that's all that matters. Okay, so that is the end of this video. I will see you tomorrow.